can call her and tell her to order some stuff and come with it tomorrow for me to bake. But things are cool. That's the issue. We that were, I'm not denying the fact that yes, we can take a cup because then they have shops, not we. And then they mix their cake anyhow. They just do it design and all of that. But we that were in the house, we want to do it to our best. So that you so that you feel like yes, you ate something good. Where is my number, sir? I can't even tell her to come with any of her friends, sure, but you'll stay in my place till after the video. Or you pay me, you compliment me too. Because my friend. Hello? What up? How far now? Where you dey? Are you sick? So you cannot even recognize my voice. Enjoy. Hey, you can't even recognize your friend's voice because I use another number to call you. Now like waiting. Now like waiting.
Hello and welcome. We're going to continue our classes now. So today we're going to be looking at chemistry. And before the other people join up to the class, I'm going to quickly give us the assignment for today. And like we all know how to get to ours. Please, Chama, can you hear me?
Yes, sir.
Okay, so let's continue. So before other people join, I'm going to quickly show us how we can track the assignment that we are going to be doing for today. So we finished 2018. We are now in 2020. So you quickly type in Tclassified.com on the YouTube. So once you get to YouTube, type Tclassified.com. You're going to see this. So click on this first one. So it leads you to our channel. So come here and type JAMB 2020 chemistry past questions. Okay. So you're going to see the, okay, this is it, JAMB 2020. So that is the assignment for today. So I'm going to copy the link and paste in your, okay, please let me share my whole screen. Okay. So this is the, you just type in Tclassified.com in the search bar of the YouTube. Then once you're in the channel, type JAMB 2020 chemistry past question, the way it is here. And so this is it, JAMB 2020, complete JAMB 2020 past question. And this is how you can get any year's past question. I told you to do the last 5 consecutive JAMB past questions for all the 4 subjects you're doing. So I'm gonna copy this link now, and I'm gonna paste it to your various WhatsApp groups. So check your WhatsApp group. You'll see the link. So play the video, use the video, and complete your assignment. Play the video, use the video, complete your assignment, and submit. Please, those of you that have already added to the groups, there is no need submitting the assignment to my personally to me. So put it on the group so that my other people, teachers, can also be able to look at your work one by one so that they can find out whether you got everything correctly. So please, anytime you're submitting the assignment, make sure you submit to the group. That is the right way to submit, okay? So let's continue. So you all know the platform we are using is this platform, EducateAfricans.com. That is where we are taking our classes from. So I'm gonna click on all courses. So once I'm in all courses, I'm gonna get to chemistry, which is the lecture we'll have for today. So all courses, we are in all courses, and I'm gonna get to chemistry. I'm gonna go down one bit, and okay, this is chemistry here. So the one by Anita and Banasov, that's the one. That's the one we are using. So once it opens, sorry. Okay. So once it opens, I'm going to go down a little bit. Okay, and see the various courses. So we've looked at a whole lot of things. We looked at the first 20 elements, and those were the things we looked at the last time. So I'm gonna go then and look at some other things. Looked at calculations in pH, acid, bases, and salt. Okay, so let's look at water. I think we look at water. Look at something that's most likely going to come out. Kinetic theory, Charles law, Boyles law. Okay. So let's look at kinetic theory of gases, Charles law and Boyles law. Have we looked at something like this before? Chama, have we done kinetic theory of gases, Charles laws and Boyles law?
From the time that I joined, sir, no.
Okay, from the time you joined, we've not looked. Okay, you didn't join
Yes,
earlier. I think we did it earlier. We did it earlier. And still look at it a little. Just wait. Just wait. A minute. Oh. Okay, so let's look at the kinetic theory of gases. Okay, so let's appreciate the kinetic theory of gases. Let's understand what this theory is talking about. So this theory describes the behavior of ideal gas. And it simply states that a gas consists of small identical particles called molecules moving randomly in all directions and colliding with each other and the walls of the container. So these are the postulates of the kinetic theory of gases. So it's describing the behavior of an ideal gas. I hope we all know that there is a difference between ideal gases and real gases. So ideal gas is an expected behavior of what gases should be. And we also have what we call the ideal gas equation. So the kinetic theory of gases describes the behavior of an ideal gas. And it simply states that gases constitute of small particles called molecules. And these molecules are moving randomly in all directions, colliding with each other and with the walls of the container. That's the first statement. And the second statement is that there is no force of attraction between the gas molecules. And number three statement is that molecular collisions are perfectly elastic. That is no loss of energy when molecules collide. And the fourth statement is that the volume of gas molecules is negligible compared to the total volume of temperature of the gas is directly proportional to the statement is that the collision of the gas molecules with the container give rise to what we call gas pressure. So JAMB is going to ask you, which of the following statements is true about the kinetic theory of gas? Which of the following statements is true about the kinetic theory of gas? So whenever you hear such question, the most likely option that they will always put, which is the correct answer, is that the collisions of the molecules with the container gives rise to what we call gas pressure. That is how gas pressure occurs. It occurs from the collision of the molecules, gas molecules with the container, with the walls of the container. So take note of this. That is the essence of the kinetic theory of gases. And like I said, the kinetic theory of gas is the theory that describes the behavior of ideal gases, not the behavior of real gases, but it describes the behavior of ideal gases. And it simply states that a gas consists of smaller particles, and these smaller particles are known as molecules, and they're always moving randomly in all directions, colliding with one another and colliding with the walls of the container. And also, the molecular collisions are perfectly elastic, meaning that no loss of energy when the molecules collide. The volume of the gas is very, very small. The actual volume that the gas is occupying in the container is very, very small. It's just that because it's moving, you think that the gas is everywhere. But when you collect the gas together, it's actually very minute compared to the total volume of the container in which the gas is put. And the collision of the gases with the container gives rise to what we call gas pressure. So take note of that. Take note of that. Okay. So having concluded the kinetic theory of gases, let's now look at the laws that come under this, which are the Charles law and the Boyles law. Then we should be able to differentiate between the Charles law and Boyles law is different from that of. Okay, so what is the statement of Charles law? So these are the gas laws that we have. Number one is the Charles law. And Charles law says that for a fixed mass of a gas, the volume is directly proportional to the absolute temperature. For a fixed mass of a gas, if you look at, can you see these two diagrams? This one is at a temperature of 100 Kelvin. This is the volume. So once you increase the volume, the temperature to 200, the volume will increase. Why? Because as you're increasing the heat or the temperature, the molecules of the gas, from the kinetic theory of gas, you remember that gases are made up of smaller molecules. So as you're increasing the temperature, these molecules, they will acquire what we call kinetic energy and they will start moving. Because they are moving, they will occupy more volume. So as the temperature is 100, this is where the volume is half. But as the temperature is now 200 Kelvin, it is now almost full. So the temperature increase is proportional to the volume increase. That's why Charles law states that for a fixed mass of a gas, the volume is directly proportional to the absolute temperature, provided the pressure remains constant. So what it means is that as the temperature is increasing, and from this graph you can see it, as the temperature is increasing, the volume is also increasing. And that's why we have this sort of graph. But make sure that it's extending from minus 273 because we are considering absolute temperature. So whenever you hear the word absolute temperature, it means temperature of temperature in Kelvin scale, not in centigrade or Celsius. So it has to be in Kelvin. So this is a typical diagram of the Charles law graph. So this is the graph of Charles law, and this is how you can indicate that as the temperature increased from 100K to 200K, the volume increased from half to 1/3. So take note of that. And this very statement of Charles law, which says that for a fixed mass of a gas, the volume is directly proportional to the absolute temperature, provided the pressure remains constant. It can be represented mathematically by saying V is directly proportional to T. Make sure that the T is in Kelvin. Now, if you're removing this proportionality sign, you have to introduce what we call the constant. This is the constant of proportionality. In order for you to change this proportionality sign to equal to, you must always introduce K. Because if you don't put equal to, you cannot be able to solve it mathematically. So you have to always change this to this. So once you're changing the proportionality sign to equal to sign, you must introduce K, which is the constant of proportionality. So the formula becomes V is equal to KT. So make K the subject, K becomes equal to V over T. So considering two instances as we are having these two conditions, this condition 1 and condition 2. So these are volume V1 and temperature T1, whereas this is volume V2 and temperature T2. And that is how you have this very organization. So let's look at an example. I want somebody to quickly solve this example for me. Somebody should quickly solve this. So the example simply says, at 25 degrees Celsius, I want everybody to write. Please make sure you're writing. You'll solve this immediately and give me the answer. At 25 degrees Celsius, the volume of mass of helium gas is 1.85 dm cubed. Now, at what temperature will the volume be 2.25 dm cubed if the pressure is kept constant? So somebody should solve that. Somebody should solve that and give me the answer. It's pretty easy. Make sure that you convert all temperatures to Kelvin. Then use this very formula. This is the formula you use. V1 over T1 equals to V2 over T2. This is the condition at first instance, condition at second instance. Somebody should quickly solve that and give me the answer. Yeah, so while all of you are solving.
No, we can't see the question.
Okay. So once I close this, I don't know the question. Oh yeah, just be looking at the question now. Somebody should be writing. Write very fast. Write very fast. Let me remove my volume. I'll be always be clicking on this so that you can see the question and write. Write very fast. So while you are solving out, I want to make a very important announcement. So on by next tomorrow, which is 27th of the month, it's my birthday celebration. So my birthday is gonna be filled with so many things, and amongst them is the quiz that we're gonna be doing that day. So once you're able to answer any question, we give you a recharge card immediately. So check the groups that you are in. We're gonna be sending the same questions. All these questions are from your JAMB past questions. So they are questions that will prepare you for your JAMB. So post it immediately. But take note, the group that you are in is not the only group that we here in Tclassified run. We have several other groups for people preparing for IJMB, people preparing for JUPEP, people in the university, people in for secondary school. So we'll be sharing the same questions for them. So anybody that gets the question first, gets the recharge card. So the recharge card, so once you send it, we send the question, because once you post the answer, we've researched. Once your specific what's it called, your specific DM, so that another person will not see. I believe most of you have my number on WhatsApp. So once you get the right answer, I will announce it in the group that you belong. So you just privately chat me up that you are the person, then I'll send you the recharge card. So we've already bought lots and lots of recharge cards, lots and lots of it. It's so plenty. The questions will just be coming. So I felt it's good I announced it to you so that you guys will take part. Even if you're following me on Facebook, it will also be on Facebook. The questions are for everybody. So that is that's the giveaway that will be given on my birthday. So make sure that you hook up and make sure you answer as much questions as possible. So we'll be giving recharge cards of 100 naira, 200, 400, 500.
Hello.
No, we are not giving 1,000. So So make sure you're ready for it. So immediately is morning, Thursday morning. 27th is on Thursday. Thursday morning we'll start the quiz section immediately. So you just be expecting it from morning. You start seeing the questions. As you're answering, we are moving forward. As you're answering, we are moving forward.
So like how many questions?
It's one question. Once we solve like this one now, if we set this question, once you get it, you get the recharge card immediately. So it's 1-1. If we can ask chemistry, we can ask physics, we can ask government. So it doesn't mean anyone you answer, it doesn't mean that you must be in chemistry to answer chemistry. So some students are actually very brilliant. So we can ask you a question in government, and if you're brilliant enough to know it, you answer, we send the recharge card to you immediately. We don't waste time. So that's what we are going to be doing on Thursday. So we might not be having this class by Thursday because after the whole event, I will want to rest. So make sure that you do your assignments. So even if we don't have class on Thursday or Friday, the assignments for those days are still there. But I will try and see whether we can have, even if we have a very short class, we might have just very short class. So make sure that you're following this sequence in this our channel, Educate Africans. That is the channel we are using. So follow all these lectures. You can see me. This is where I just explained it. The same thing I'm teaching you, you can also find out from here. Then on that day of my birthday, we are launching we have an automated sales company where we sell a lot of things. We sell things that you use as a student, textbooks, or any kind of books you have you need as a student. We're going to be selling it on the platform. So we're going to be showing you those platforms. We are launching it that day. So we want you to patronize us. If you go to, it's a multi-vendor website. So people sell a lot of things on the website. So if you want to buy something and you know that our platforms are helping you do your JAMB and learn your JAMB, you have to patronize us in other things we are doing so that we can have enough finance to be buying data, employing teachers, doing research for you. I hope you are clear on this. Tika, are you clear on that?
Yes.
Tika, what are you going to be buying from me?
So I will check on that day.
You will do what?
I will check on that day.
Okay, you check on the website on that day. We're selling things like you see these are bracelets, fine ones, customized ones. We'll be selling your past questions. The whole booklet you will buy will ship down to you. We're going to be doing a whole lot of things on the name of the website is abujaauthors.com.ng. So we're going to have a whole lot of things on it. Customized, very, very nice products. You understand? And it's a multi-vendor website. That means anybody can sell anything. So even if you have something to sell, you can create an account on the website and start selling. So it's a new product we just pushed into the market, and I want you guys to finish. Okay, so who's able to solve this problem? Who is able to solve it?
So I got 365 Kelvin.
You got how many?
365 Kelvin.
Okay, so let's watch out how it was solved. So you can see that the volume, we said V1 is 1.85 dm cube, and T1 is what? 27, which is what is given in centigrade. But we now have to add 273 to it to give 300 Kelvin. Then V2 is 2.25 dm cube. So what is going to be T2? So you said you got what?
I got 3649, approximately 365.
Yeah, I think that is perfect. That's a perfect answer to that. Okay. So, and I think it's very easy. Choma, is it easy to solve? Do you think it's easy?
Yes, sir.
Blessing, do you think it's easy to solve?
Yes, sir.
Okay, he's on Techno. Come on. What's your name? Who is the person on Techno? Come on. Can you unmute yourself and talk? So I hope you guys know you're going to be very fast as you're solving in JAMB, very fast. Before you see, you've written V1, T. But once you're seeing any problem like this, just put them in V1 and T1 immediately. So this is the answer to that. 27 plus 270, 300. V1 is 1.85, V2 is 2.2, T2, 2.25, T2, you don't know. So make T2 the subject of the formula and solve out. So you can see where it was solved. So the answer is either 364.89 or that is in Kelvin. Or if you want it in Celsius, it's gonna be, you just subtract 273 from it to get this. Okay, can we try the second one? Can we try the second one? Can somebody try the second one? So you can see, okay, this is not actually the second one. This is part of this first one. It's part of this first one. Okay, so let's move down to Boyle's law. Let's move down to Boyle's law. So we have Boyle's law, we have combined gas law, and we have the ideal gas law. Okay, so let's look at Boyle's law. So who can tell me the statement of the Boyle's law? Very similar to what Charles stated. So the Boyle's law states that at yeah, sorry, my data finished and I was logged out. Can we see me now? Chick, am I back?
Yes, sir.
Yes, sir.
Okay. Okay, so these are typical diagrams of Boyle's law. These are, you know, Boyle's law. When you see Boyle's law, so it's the graph is like this. Charles' law is normally like this. So once you write the volume and the pressure, it's like this for Boyle's law. So these are other forms of this diagram, but you notice what is happening here. They did not write the volume here. They wrote 1 over V. So if you want it to look like Charles' law, then it has to be 1 over V and P. So take note, they might just draw this, and they normally draw diagrams of these laws and tell you to identify the one that is Charles' law or Boyle's law. So you have to take note of the graph. So this is the normal graph. This one is a modified one when you are putting 1 over V or 1 over P against V. And this is PV against either P or V. So take note. And this is the mathematical representation of Boyle's law. V is inversely proportional. Once it's inversely, it has to be 1 over that value, 1 over P. So if you're changing this proportionality sign to equal to, you have to introduce the constant of proportionality K. So if you make the constant of proportionality K the subject of the formula, then you have to take this over because VP is equal to K. So at 2 instances, you're going to have PV1, P1V1 is equal to P2V2. So we're going to have this equation, this problem. So somebody should solve this problem immediately for me and tell us the answer. So it says, consider a gas cylinder of 50 liters of oxygen if the pressure of the gas in the cylinder is 15.7 atm at a temperature of 21 Celsius, what volume of oxygen can you get from the cylinder at 21 degrees Celsius if the atmosphere is now 1.0? So you can see that the temperature is constant, which is typical of Boyle's law. So find the what? Volume, V2. So somebody should quickly solve for V2 and tell me the answer immediately. You can see we are enjoying this. So use the formula P1V1 equal to P2V2 and find the answer. Somebody should get that. I want fast fingers. Whenever I give an assignment, make sure I'm pressing this back so that you can see the question. You know this is JAMB that you're writing. JAMB is time. Time is a constraint in your JAMB. So once you see a problem like this, be fast. Just quote the formula immediately, substitute. P1 is equal to the V2. Sharp, 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 sharp. You're done. That's how you're supposed to behave. Uja, I hope you know Monday, next tomorrow is my birthday.
I'm not saying it.
So,
I saw the
IV,
I saw the IV.
Good. So keep your stomach free that day. Both food and drinks, everything will be available.
What's the
Is both here and the house. It's not, we are not doing it like a, yeah.
But nobody should come.
Wait now, so that we'll talk after the class.
Oh, it's
We'll let them give you something. Okay. Just 10 minutes.
You already said 5, now it's 10.
Okay, 5 minutes. 5 minutes. Yeah, who is able to solve the problem? Anybody? It's pretty easy. P1V1 equal to P2V2. Who can tell me the P1? P1 is what? Pressure 1, which is 15.7. What is V1? V1 is 50 liters equal to P2. What is P2? P2 is 1 atmosphere. What is V2? You don't know V2. So make V2 the subject of the formula and that becomes the answer. Okay. So who is able to solve it? It's pretty simple, pretty easy. Pretty easy. So let's look at combined Charles law and Boyle's law. I want us to finish the whole of this before we close. Combined Charles law and Boyle's law. Combined Charles law and Boyle's law. So note that the combined Charles law and Boyle's law is different from the ideal gas equation. So after this, we'll look at the ideal gas equation. So this is what we call combined gas law. A gas sample is described complete by the quantities of temperature, pressure, and volume and amount of gas. So Boyle's law is stating that V is inversely proportional to P, whereas Charles law is stating that V is directly proportional to T. So if you combine the two of them, you get this law. You get this very equation that says P1V1 all over T1 is equal to P2V2 all over T2. And with that, we also have a problem to solve. Who is able to finish the first one I gave? Take away, are you able to finish it? Take away, are you able to finish it? Chika cannot hear me. Buchi, are you there? Choma, can you hear me? Choma, can you hear me?
Oh, sorry, my network is correct.
Okay, so who was able to do that first one? Can you guys hear me?
Sir, your screen went
What?
on. Your screen.
Okay, my screen comes and goes.
No, sir,
But
please
is it
remove
showing
that.
I should remove what?
It's covering the screen. It's covering the question.
No, this is not the question now. This is a new question. Were you guys able to
Oh.
solve the one I gave in Boyle's law?
I did not see that one. My network was correct.
Okay, your network was back. Choma, what about you?
Sir, same here. He went on hold.
You did what?
He went on hold.
Okay, I went on hold.
Yes, screen.
My screen.
Yes.
Okay. So please take note of the general gas equation. P1 V1 over T1 equals to P2 V2 over T2. So this is a subsequent question that is following it. Please, all these videos are there for you. After this class, you can just go to our platform, educateafricans.com. Go to these topics, check out these problems. You see the way I solve them. So finally for today, before we close, let's look at the most popular gas equation, the ideal gas equation, which you're going to be seeing a whole lot in your JAMB. So you need to know how to use the equation to solve problems. So let's look at the ideal gas. So what is the difference between a real gas and an ideal gas? Ideal gas is the actual way gases behave, the actual way they behave. So they don't actually behave the way you think they should. So real gases are real gases. Whereas ideal gas is the way you think or the way you plan a perfect gas to be. The ideal gas is the perfect gas. So ideal gas, apart from the general gas equation, considers what we call the Avogadro's law. It takes care of the fact that gases actually they exist in terms of molecule. They have some weight, small mass. So it takes care of that. Unlike the other one that says that, unlike the ones we are looking at before. So in ideal gas, we are going to see the effect of number of moles, N. So Avogadro's law states that the volume of all gases at the same temperature and pressure contain the same number of moles. So volume of all gases contain the same number of moles or molecules, which you can represent by saying that V is proportional to N, where V is volume, N is moles. Then V is now equal to Kn. When you see you're changing the proportionality sign to equal to, you have to introduce the constant of proportionality. So what is this saying in essence? You have 3 moles of hydrogen plus 1 mole of nitrogen to give you 2 moles of ammonia. So we have 3 volumes here. So these moles can be likened to volume. And this 1 mole of nitrogen here can be likened to also 1 volume. And these 2 moles of ammonia here can be likened to 2 volume. These 2 moles can be likened to 2 volume. So you can see that moles and volume are used here interchangeably, telling you that there is similarity in them. So the summary of these gas laws, where you consider the Boyles law, the Child's law, and the Avogadro's law, you bring them together, you have what we call the ideal gas equation, which states PV is equal to nRT. So this is the ideal gas equation. This is a very popular equation. You're going to see them in your chemistry 101 when you enter the university. It's still going to exist there. So take note of it. PV equal to nRT. And we have a problem under here too that you can use in solving it. So play this video, solve out those problems, see the way they are used. And most importantly, like I said, I've gone to this is our YouTube channel. So once you get to Tclassified YouTube channel, in the search column that is down here, type JAMB 2020 chemistry past question, you see it. So this is the current assignment. Everybody, have you all submitted the biology 2018? Chika, have you submitted yours?
Yes, sir.
Okay. Choma, have you submitted yours?
Yes, sir.
Please, everybody, make sure you submit all these assignments. Make sure you do all these past questions. Like I said, if you follow our video, we did not just answer them, we answered with explanation. Okay. So thank you. See you when I see you. I'll be expecting your birthday gift. So send your birthday gift to me. Send them to me. If you're sending me a recharge card, if you're sending money to my account, if you need my account number, just tell me that you need my account number. I'll forward it to you immediately. No gift is too small for me. I'll accept all. Choma, yes?
Sir, please, before we leave, I have a question.
Yeah, I'm listening.
Okay, it's under radius reaction. I've been trying to get it. Oxidation is the loss of electron, right? An increase in oxidation number.
Yeah.
Y reduction is the gain of electron lost
Good.
in oxidation number. But
Perfect. That's what it is.
sir, why seeing some examples, I saw that oxidation, like loss of electron, let's say chlorine as an example, it's gaining an electron plus 1, making it 18, right? But then you see -1. I don't know how to. It's really confusing.
It's gaining what?
It's gaining an electron now. Let's say hydrochloric acid.
Yes.
So it will collect one from hydrogen because it's not stable, making it 18, right?
Yeah.
Chlorine. But then the ion, you see -1. I know that -1
Yeah.
means
Chlorine is -1. You understand? Because it gains electron. All the non-metals, you normally put minus for them. Is that clear?
okay. So
But
it's not
they are mostly oxidizing agents. Chlorine is an oxidizing agent.
okay.
Is that clear?
Yes,
Chlorine is an oxidizing agent. Most of those are non-metals, whereas the metals are mostly reducing agents.
okay.
So chlorine accepts electron, it gains electron. And you, like you said, gaining of electron is what? It is reduced. So the oxidizing agent is reduced in the end of the reaction because it is oxidizing the other one. So it is actually reduced. Every oxidizing agent is reduced.
Okay.
Do you understand it now? The
Yes, sir.
oxidizing agent is actually reduced because it is oxidizing the other element that both of them are involved in the reaction. So just like oxygen is an oxidizing agent. In fact, that's the major oxidizing agent by the fact that it is oxidation. So, but oxygen is actually reduced.
Okay.
And that is because it does what? It accepts electron. And accepting of electron is oxidation. You understand? So, but it's reduced in the end, but it's oxidizing the other element, which both of them are combining in the redox reaction.
Wow.
So I think maybe still try and play the video on this very lecture, and the very question you're talking about, you can paste it, send it to me on WhatsApp so that I'll look at it and see whether they got it right or whether the problem is the way you're trying to understand it. Because it's actually a little bit tricky. But just know that in the end of every reaction of an oxidizing agent and a reducing agent, the oxidizing agent is reduced in the end so that it can perform that oxidation of the other one.
Thank you very much.
Thank you. Yes, so as I was saying, make sure you send in my birthday gift. I will expect the gifts from all of you, everybody. Thank you. See you when I see you. God bless you. Do my assignment. Make sure you do the assignment. The assignment